Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Welcome back. Problem 3-28. So in this problem, if P is equal to 150 kilonewton, determine the elastic elongation of rod BC and decrease in diameter. Rod BC is made up of A36 steel and has diameter of 40 millimeter. So we will start from given data. It is given that P is equal to 150 kilonewton. Clear? And rod BC is made up of A36 steel. So it is A36 steel. This is rod BC. Also, the diameter of this rod BC, DBC, our original diameter is equal to 40 millimeter. So what we have to find is, first we have to find the elongation of rod BC, that is elongation of rod BC, and the second part is decrease in diameter in its rod, which is delta D. So let's start with the solution. The first step is that we will draw the free body diagram and we will find the force in rod BC. So I will draw the free body diagram over here. Let this is rod, this is beam AB. Clear? So when pin connection is removed, so definitely there will be horizontal and vertical forces at this point. Let the horizontal force is AX and the vertical force is AY. This is point A, this is point B. At this point, from a distance of 1 meter, there is a load P, and from this to there is another load at a distance of 1 meter from P. So this distance is 1 meter and this distance is again 1 meter. And the remaining distance from this P to C is also P to B is also 1 meter. Now at point B, this rod BC, the force in this rod BC will be this one, and let this force is FBC. So you can see if this makes an angle of theta, so tangent of theta will be equal to, I will write over here, tangent of theta will be equal to 1 over 0.75, and theta is equal to tangent inverse 1 over 0.75, which means that theta is equal to 53.13 degree. Clear? Now this force will have two components. One is in horizontal direction and other one is vertical component. So this force FBC X and this force will be FBC Y. Now we are interested in find out this FBC, so we will apply the equilibrium condition that sum of all moment about point A is equal to 0 and taking the counterclockwise movement is positive. So these two forces are passing through point A, so there will be no movement. Due to this force there will be movement. So this force is 150 kilonewton, so 150 kilonewton into 1, because the perpendicular distance is 1, and this is producing clockwise movement, so that is taken as negative. Also this force is also producing clockwise movement, and that will be equal to minus 150 into perpendicular distance is 2 meter, because you can see 1 meter plus 1 meter is 2 meter. The third force which is producing movement is FBCY, the vertical component, because the horizontal component is passing through point A, it will not producing any movement, only the vertical component is producing movement, and this vertical component will be equal to FBC sine of 53.13 degree. Clear? And the perpendicular distance will be 3. Their sum must be equal to 0. So when you solve this, you will get FBC is equal to 187.5 kilo Newton, 187.5 kilo Newton. Now you have this force. Clear? You can find the stress in BC, rod BC. So stress in rod BC is equal to force of BC divided by area of BC. So force in BC is 187.5 into 10 raised to power 3 Newton divided by area, and diameter of rod is given, which is pi by 4, into diameter is 40 millimeter, original diameter. So in term of meter it will be equal to 0.04 meter, and it's square. So when you solve this, you will get the stress in BC, rod BC, which will be equal to 149.21 megapascal. Now I have this stress. I will go to find the strain. As we know that stress is equal to modulus of elasticity into strain. Clear? And this strain will be equal to strain in term of BC, it will be equal to BC and BC. So epsilon BC will be equal to stress BC divided by E of rod BC, and E of rod in BC, E of rod, since it is A36 steel, so you have to go to the table. I will show you. You have to go to the table. A36. So E is 200 gigapascal. You can see this value, 200 gigapascal. So stress is 149.21 into 10 raised to power 6 Pascal, and E is 200 gigapascal. So 200 into 10 raised to power 9. So from here, when you calculate it, you will get strain in BC, which is equal to 0.746 into 10 raised to power minus 3 millimeter per millimeter. Now you have this strain. So from this strain we know that strain BC is equal to change in length of BC divided by original length of BC. Now original length of BC can be found out by taking the Pythagoras theorem. So length will be equal to 1 square plus 0.75 square under the root, and when you calculate it, this length will be equal to 1.25 meter, or it will be equal to 1250 millimeter. So this is the length of this rod BC. We are interested in find out change in length of BC. So change in length of BC is equal to length of AB into strain AB. Length of AB we have calculated, that was 1250 millimeter, and strain is 0.746 into 10 raised to power minus 3. So we will get change in length of BC will be equal to 0.933 millimeter. So this is the answer of our first part. Now we will move towards second part. In second part, it has been asked to find the change in diameter. Clear? So for change in diameter, we know we will use this formula. Poisson is equal to minus lateral strain divided by normal strain. We have normal strain, we do not have lateral strain, and Poisson ratio, the value of Poisson ratio can be found from this table. So 0.32. This is the Poisson ratio. So V is mu is equal to 0.32. Normal strain is in BC is equal to, this is normal strain BC, is equal to 0.746 into 10 raised to power minus 3, we do not have lateral strain, so lateral strain can be find out. Lateral strain will be equal to minus mu times epsilon BC. So minus nu is 0.32 and BC is 0.746 into 10 raised to power minus 3. So when you calculate it, you will get the lateral strain. Lateral strain will comes out to be minus 0.2387 into 10 raised to power minus 3 millimeter per millimeter. Now this is the lateral strain. Now from this lateral strain we will find the change in diameter. Since this lateral strain is equal to change in diameter divided by original diameter, and original diameter is diameter of BC. So from here we can get change in diameter is equal to lateral strain into diameter of original diameter of the rod BC. So minus 0.2387 into 10 raised to power minus 3 multiplied by original diameter of rod B was 40 millimeter. So this is change in diameter. So we can also write delta D is equal to change in diameter, because it will confuse, which is delta D. So change in diameter comes out to be, when you multiply it, it will be minus 9.55 into 10 raised to power minus 3 millimeter. This means that diameter of rod BC is decreasing and the change in diameter will be minus 9.55 into 10 raised to power 3. So this is the answer of our second portion. I hope you have enjoyed this video. Thank you for watching and supporting me.